In this Cytorial, we're going to talk a little bit about fluidic systems and understand the differences between the CYTOFLEX and other instruments. Most flow cytometers these days operate using a system of constant positive pressure that drives sheath fluid through the flow chamber. We use the well-known principle of hydrodynamic focusing in the flow chamber. When we change the pressure of the sheath, we change the flow rate of the sample. So what's the core technology in the CYTOFLEX? The CYTOFLEX uses a peristaltic pump that is quite different to many other cytometers. So it's important for us to look carefully at this technology to see how it works and how it impacts the quality of the data produced. So how does the peristaltic pump impact the way the sample flows? Traditionally, we think of peristaltic pumps as creating pulses along the fluid. And we know that pulses would not be desirable in flow cytometry. So key questions then might be, can the CYTOFLEX produce a perfectly smooth sample flow? Can it operate in both fast and very slow speeds? What about the minimum and maximum volumes that you can sample from? All these are legitimate questions that should be asked of any system. Let's look inside the CYTOFLEX. If we go through the fluidics of the CYTOFLEX, we see the peristaltic pump is here in the center of the instrument. The sample is collected from this sampling station and transferred to the flow chamber, where the hydrodynamic flow creates a nice single particle stream passing by each laser line and out to the waste station. What we see when we monitor sample number versus time is a perfectly flat line. This implies that the peristaltic pump is not creating pulses, which is really important. There is a good reason for this, and it's related to the unique design of the pump so that any potential pulses are removed using a clever design feature of the pump itself. By the way, it's important that you always collect number versus time on every sample, as this gives you confidence that you're getting constant sampling during the collection period. Many folks forget to collect these parameters, and you should make sure you're not one of them. It's a critical QC principle that was established by Jim Watson back in the 1980s. And if you don't remember who Jim is, go look up his work and take a look at this manuscript. So whenever you're making a histogram of a data set, make sure you also collect time so that you can be sure your sample rate is stable. So what does this say about the stability of the CYTOFLEX fluidics? It can maintain a constant flow rate. No oscillations come from the pump. It is capable of attaining a high, stable flow rate. It maintains excellent hydrodynamic focusing. In summary, we can say that peristaltic pumps are efficient fluid delivery systems. The unique design of the CYTOFLEX pump removes pulsation effects. The CYTOFLEX can collect perfectly stable data using a peristaltic pump at a reasonable speed while maintaining sample flow.